So let's take a look at adjusting some of these surface tessellations. When we looked at our last renderer, we could see that while the shading quality was nice, there was some obvious problems with the tessellation, and that's going to be dealt with by editing things within the approximation editor. Mental Ray will use Maya's default tessellation stuff, so I always choose to edit those things within the attribute spreadsheet. So if I select these objects, for example, and I go into the attribute spreadsheet and I go under tessellation, you have your U divisions, V divisions, curve tolerance, explicit tessellation, so on and so forth. Mental Ray will follow these settings to a certain degree. At some point, sometimes it stops following it, and no matter what numbers you input into that, you don't seem to be able to push the tessellation or the rendering quality of that tessellation to any different level. It seems to always render out with a certain level of, for example, bumpiness or something like that. You're getting tessellation errors like faceting. So then it becomes necessary to access something called the approximation editor, and that will allow you to use Mental Ray's own custom tessellation inputs in order to derive the scene setup. So I'm going to go to a handy dandy shelf I made here called Mental Ray. AE stands for approximation editor. And again, if you wanted to make your own shelf, if you went to new shelf, I'm just going to call this my demo shelf. And I have my demo shelf here, and I'm going to go under rendering. Underneath rendering, I'm going to go to, or I'm sorry, underneath Windows, Render Editors, Mental Ray, I'm going to go to Approximation Editor. And by holding down the Shift and Control keys, it's going to pop that icon up onto my shelf. And when I click it, I have my hotkey for, or my shelf item for pulling up, in this case, the Mental Ray Approximation Editor. Just to look at a couple of other things within there, underneath the Windows Render Editors Mental Ray, you have Approximation Editor, which is something we're going to talk about in a second. You have Custom Text Editor, which is using either custom objects or custom shaders within your scene. Map Visualizer, this is a tool that's been provided to help you understand the way that samples, for example, are being spread out in the scene. And we'll get into this when we start talking about global illumination in Final Gather. And then you have in here Shader Manager, and previous to this version of Mental Ray, you had to custom load your shader libraries, and in version 6.0 you can have it load these libraries as needed by just simply telling it within the shader library which library to load and to unload. So the again, menu item that I'm looking for inside of here is under Mental Ray Approximation Editor, and I have my shelf up here to do that with. So I'm going to step back through my shelves. You can see that I like shelves. Mental Ray Approximation Editor. And inside of here, we have a couple of different options for creating an approximation. So what's going to happen inside of here is once I create this approximation, I'm going to assign it to the surface. And that surface, when pushed out into Mental Ray, will be told to derive a custom surface node. And for example, I could say surface approximation for NURBS. I can create an approximation for a NURB surface, for a trim surface, which would be one of Maya's modeling tools. I can tell it to trim a hole in a surface, which is just a quick and dirty way of poking a hole into a NURB surface. I could tell it displacement approximation, how does it derive tessellation information for displacement, and then subdivision surface. If I'm creating a tessellated sub-D model, how's it going to do that? So in this specific case, I'm just going to pick one surface so we can just see how this does this once, and I want to create a surface approximation node for a NURB surface. So initially, we can see when I pick this surface, inside of here it says derived from Maya. So the tessellation settings currently are coming from Maya. If I want to tell it to use a custom Mental Ray shader node, or I'm sorry, custom Mental Ray approximation node, then I can tell it to just create, and all of a sudden Mental Ray shader surface approx 1 shows up, and I can tell it to edit. And within this dialog, you've got a bunch of different settings in here which will help you derive whatever your approximation settings are going to be. Now, if I had multiple surfaces that I want to assign this to, I just simply select the multiple surfaces and I tell it to assign. Or if I am initially creating an approximation, I just tell it to create, and it will create an approximation that includes all of those surfaces. Now, if I want to see that approximation after it's been created, I can tell it to show in hypergraph. So I'm going to click this guy open, tell it to assign, and it'll open up the hypergraph window. And I have my mental ray surface approximation right here, and then I can see all the different surfaces that this has been mapped to. So in this scenario, I've only got one mental ray surface approximation that's being mapped to all these different things. If I tell it to create multi, it's going to create a new surface approximation for each object that I have selected. So I'm going to say multi show in hypergraph, and I'll tell it to create. And you can see we have multiple surface nodes that are being assigned to all the different surfaces. So now each one of these surfaces has its own unique tessellation settings. And that's fine if you want to work that way. A lot of times I find that creating one surface approximation, for example, a curved surface will be appropriate, and then another surface approximation for a more flatted surface will be appropriate. So I can maybe get away with a couple of different surface approximations as opposed to one for each and every surface. So I'm going to reopen this scene so I don't have all those approximations anymore. And go back to my shelf approximation editor. Take a look at what we've got in here. Again, I'm going to select a surface. Actually, I'm going to select the entire set of surfaces and just give it all this one tessellation setup. I'm going to select all the surfaces. I'm going to say a single application. I can tell it to show in hypergraph if I want to. I'm going to tell it to create. And I see all the different surfaces with this one approximation node. Now I'm going to go to edit. And again, there's a couple of different settings in here that I can adjust. You have all of your different initial settings as presets. And then I can go through here and set things up individually. There's a couple of different ways that you can do this. One of them is parametric, regular parametric. Parametric is essentially the same thing as doing Maya's tessellation settings of explicit. It's going to introduce tessellation in areas where the isoparms on the surface is dense, and it's not going to have as much where the isoparms aren't dense. So if I want it to do that, then I can go on ahead and tell it to use parametric. If I tell it to use regular parametric, it's going to do the same thing as the basic tessellation pattern within Maya, and that is it's going to just try to tessellate the entire surface uniformly regardless of the density of isoparms on the surface. The LDA, or the length distance angle, will allow you to set up specifications. I want you to subdivide the surface based on a certain length or a certain distance or a certain angle. Spatial will allow you to take into consideration where that object is to the camera, and it'll tessellate accordingly. And curvature is only included for backwards compatibility. So what I'm going to do here is use parametric, and that means it's going to tessellate the surface as the isoparms become more closely spaced on the surface, and I'm going to use a tessellation of 2 by 2. Let's see what that looks like. Come in here and render this out. On this particular scene, I've stripped out the shader because I don't want to take too much time in calculating that shader. I just want to show you what these surfaces look like properly tessellated. So I think you can see with just a default tessellation setting, we're getting some very nice, using parametric 2 by 2, we're getting very nice tessellation. The surface is nice and smooth, and it was a pretty light render. So that's how to use the approximation editor. We'll go through this more in a minute when we talk about displacement underneath here, but for now, if you need to custom tessellate a surface within MentorRay, that's just, you just select the surface and tell it to create a MentorRay approximation and adjust those settings accordingly. Also, something to note is that if you need to edit these things on the surface, you can either open up this dialog and select the surface, and it'll pick the approximation that's assigned to the surface, or you can go into your hypergraph and take a look at it in there. I can look at this surface and I can see my MentorRay surface approximation.